Today I'm going to discuss how to use the trades triangle. The trades triangle can be used for various formulas that have three variables. So an example for this would be Ohm's law. The formula we would end up using, or the law we use for electrical voltage, current, and resistance. So the formula for Ohm's law comes out of the idea that it takes 1 volt to move 1 amp through 1 ohm of resistance. So 1 volt to move 1 amp through 1 ohm of resistance. The way we express that in a formula is we say voltage is equal to amperage, which is usually shown as an I, multiplied by resistance. Or another way would be E for electromotive force is equal to current times resistance. Now, understanding the trades triangle is understanding how to put these three variables into the triangle and then find its use. When we look at the formula, we can see that we have two pieces that are being multiplied by each other. When we look at the triangle right here, we actually see this line along the lower section, and that could actually be understood as a multiplication. So what that means is that we take the I right here and we would put it in that box, the R into this box. So we would say I and R belong on the bottom because they're multiplied by each other. We see we only have one spot left, so that means E or V would go on the top. The way we would use this then, or the way it's useful, is that let's say we used a multimeter, we measured voltage, and we said we had 12 volts at a battery. And let's say we turn on a light bulb and we saw that we had 3 amps going through the circuit. But we don't know what the resistance value is. What we can do is plug those numbers into our triangle, and we can see 12 would go on the top because it's our voltage. We would see 3 amps goes on the bottom because that's our current. And what we would actually see is that this is the same as 12 divided by 3. And we'd understand that we're filling in for the piece we don't know, being 4 ohms. This can be used for any of our 3-piece formulas. So let's say hydraulics for that matter. So Pascal's law is expressed as a hydraulic formula, or a formula that explains to us hydraulic principles. So Pascal's law is force of a cylinder, let's say, is equal to the pressure within the cylinder acting against the area of the piston. Now, we would do the exact same thing. We would see that pressure is multiplied by area. Pressure would go in the bottom, area would go in the bottom. So pressure, area, that only leaves one space left for force. To understand how to do this, again, let's say I wanted to create 10,000 pounds of force in a cylinder to lift up a vehicle. So I don't know what the pressure is going to be required, but I know the weight of my vehicle and I know the area of my cylinder. Let's say it's 10 inches squared. What we can do is put those numbers into the triangle then, saying I have a 10,000 pound vehicle that needs to be lifted by a 10-inch squared cylinder. And so we go 10,000 pounds divided by 10, we'd cancel those zeros, and we'd see that I need 1,000 PSI to lift the vehicle. So using the triangle, we can actually fill in for what we don't know. Move the pieces we do know into the triangle and use the structure of the triangle to help us. This would be the division line, and this is our multiplication. So anything in these lower sections get multiplied, anything in these sections are divided. Now, if the formula was given to you in a different form, so I'm just going to manipulate the same formula here, and I'm going to say that pressure is equal to force divided by area. If that was how it was expressed to you, and it's still a 3-piece variable, what we see is that force is above area. So then force needs to be above area. And then we would take this last piece of pressure and we would put it in the bottom of the triangle. So it doesn't really matter how the 3-piece formula is given to you. You can put those 3 pieces into the triangle and then again solve for the piece that you don't know.